All right, so equation number 9. Now, you can think your way out of the correct solution to this one by just kind of haphazardly multiplying these out. But once you have the left side of an equation factored and you have the right side 0, you just set each factor equal to 0. Cotangent of theta minus 1 equals 0, and secant of theta minus 1 equals 0. So the only values of theta that would make this equation work are the values of theta that would make each factor equal to 0. Because when two or more factors multiply together to give you 0, the only way to solve that is if one of the factors is equal to 0. It goes back to that property of real numbers, zero product property. So anyway, adding 1 to both sides here, we get where is the cotangent equal to 1? It's the same place that the tangent is equal to 1. Pi over 4, first quadrant, and then the third quadrant, 5 pi over 4. So we have those. And then we have where is the secant equal to 1? Now, if you remember, we talked about the solutions need to be on the interval from 0, including 0, to 2 pi, but notice that we're not including 2 pi, so you don't need to include 2 pi. But the secant is equal to 1 where the cosine is equal to 1, and that's where theta is equal to 0, comma 2 pi, 4 pi, and so on. But we're only seeking values of theta in between 0 and 2 pi, but not including 2 pi. So if we want to, we could box around that, or we could just probably shouldn't have put a box around that, but we'll put a box around the final answer. So this is the final answer in red. So pi over 4, 5 pi over 4 make that factor equal to 0, and 0 makes this factor equal to 0. All right, last one. Factoring. So I find it easier to factor when I just write S for sine of theta, and if we don't overthink things too much, I mean, FOIL method, it's a trinomial, quadratic trinomial, and we've got factors, so first times the first has to equal the first factor, and then this is a 5 here. So we have two options, a 5 in the first position and a 1 in the second, or a 5 in the second position and a 1 here. 2 times 5 is 10. That's going to get us closer to 9. Minus 5 there. So 2s times negative 5 is negative 10s. And then a positive 1s is going to give us that middle factor. So now that we have our polynomial factored, we can go ahead and put that sign back in. So we have 2 times the sine of theta plus 1 equals 0. And we have the sine of theta minus 5 equals 0. Now, this has no solution because if you added 5 to both sides, you'd get sine is equal to 5. Well, sine can't equal 5. Sine can be only as big as 1. So then we have this one, this equation here, where if we subtract 1 and divide by 2, we get the equation sine of theta equals negative 1/2. And I think we already had that up there somewhere, didn't we? Yeah, oh yeah, back in problem 8. So sine is negative 1/2, where theta is equal to 7 pi over 6 as well as 11 pi over 6. And that's it. Hope that helps.